You know, there's a reason why people say that sugar is addictive. They've experienced it themselves. We all seem to have a relationship with sugar that's kind of love-hate. We know it doesn't do us good, yet we keep craving it. So today, let's go deeper and explore how sugar literally hijacks our brains. Let's delve into some research and see what scientists have uncovered about this sweet yet sinister relationship. And while you're here, if you haven't already, please consider subscribing to stay updated with all our latest videos. Alright, let's dive right in. At its simplest, sugar affects the brain by hijacking its natural reward system. This system is primarily driven by a neurotransmitter called dopamine, which is kind of like a messenger in the brain. It's released when we do something that our brain deems as pleasurable or important, reinforcing the behavior, so we want to do it again. Now this makes sense when it's something essential for our survival, like eating nutritious food or even bonding with others. But sugar, well, it's a different story. Here's the thing. When we consume sugar, specifically simple sugars like glucose and fructose, it triggers a much more powerful and potent release of dopamine than whole foods like vegetables or even complex carbohydrates like oats. Let me explain. First, when you consume sugar, it's rapidly broken down and absorbed into the bloodstream, causing a spike in blood glucose. This increase is detected by the brain. At the same time, the taste of sweetness on your tongue sends signals via the cranial nerves to the brain. Now both these inputs work together to activate the brain's reward centers, particularly a pathway called the mesolimbic dopamine pathway, which originates in an area of the brain called the ventral tegmental area and projects to another area called the nucleus accumbens. It's here where dopamine is released in large quantities, creating a sensation of pleasure, euphoria, and a quick energy boost. That's the sugar high you've probably experienced before. Here's the problem. The brain is designed to maintain balance, a state called homeostasis. Repeated, massive surges of dopamine in response to sugar cause the brain to adapt to protect itself. This adaptation leads to two key changes. 1. Downregulation of dopamine receptors. Basically, the brain reduces the number of available dopamine receptors. Think of it like turning down the volume on a radio. This means the same amount of sugar no longer produces the same level of pleasure. This is known as building a tolerance. 2. Reduced natural dopamine production. Your brain may also start producing less dopamine on its own. This is like changing the channel to a station with a weaker signal. The result, you now need to consume more sugar to achieve the same pleasurable feeling you once got from a small amount. If you don't get that sugar, you might experience withdrawal-like symptoms like low mood, irritability, brain fog, and intense cravings. And this, my friends, is a classic hallmark of substance dependence. And yes, sugar follows a very similar pattern. But that's not all. There's more to this story. So next, let's talk about another part of the brain that is heavily impacted by sugar, the hippocampus. This area is like the brain's central hub for memory formation and learning. Interestingly, it's also rich in insulin receptors. Now, insulin is not just for regulating blood sugar in the body. It also plays a crucial role in brain function. In the hippocampus, insulin helps strengthen the synaptic connections between neurons. This process is vital for forming memories, but here's where things take a turn. A diet consistently high in sugar leads to insulin resistance, and this doesn't just happen in the body, it happens in the brain too. When brain cells become insulin resistant, they can't effectively take up glucose or respond to insulin signals. Consequently, the hippocampus, especially vulnerable to insulin resistance, starts malfunctioning. This impairment disrupts the brain's ability to store and retrieve information. Several studies have linked high sugar consumption to a reduced synaptic plasticity, which is the brain's ability to change and form new connections, shrinkage of the hippocampus, and deficits in memory, learning, and cognitive function. And let's not forget about the emotional toll. Consuming sugar can trigger a roller coaster of emotions. The initial surge of dopamine and energy can cause short-term euphoria or hyperactivity. Then comes the crash. The body responds to a sugar spike by releasing a large amount of insulin to clear the glucose from the blood. This sudden increase in insulin can cause a rapid drop in blood sugar levels, hypoglycemia. And this drop triggers the release of stress hormones like cortisol and adrenaline. These are your body's fight or flight chemicals. They can cause anxiety, irritability, shakiness, and brain fog. Over time, this cycle can contribute to long-term dysregulation of the body's stress response system and is linked to a higher risk of developing mood disorders like depression and anxiety. Now, let's shift our focus to another critical area affected by sugar, the hypothalamus. The hypothalamus is like the ultimate control center in the brain, responsible for maintaining the body's internal balance, regulating hunger, thirst, and energy balance. It produces hormones that make you feel hungry, ghrelin, and full leptin. The problem arises when you consistently consume sugar. Over time, this can lead to leptin resistance, similar to insulin resistance. When leptin's message telling your brain you're full is ignored, the brain never gets the message that energy stores are sufficient. As a result, the brain perceives a state of starvation even when the body has more than enough energy stored. This can drive increased hunger and a desire for high-calorie foods. It's almost like your brain is always on the lookout for the next meal because it thinks the body is in a starved state. Ultimately, this disruption in appetite control makes it incredibly difficult to control food intake, leading to overeating and potentially weight gain. So there you have it. Sugar affects the brain in numerous ways, from hijacking its reward system to disrupting memory, influencing mood, and controlling appetite. The real issue lies in the excessive and easy access to added sugars in our modern diets. These are the sugars found in processed foods and drinks like candies, cookies, and sodas. These foods can cause rapid and significant spikes in blood sugar levels, leading to the cascade of effects we've discussed. On the other hand, the sugars naturally occurring in whole fruits come with fiber, water, and vitamins, which slow down the absorption of sugar. This means that fruit does not cause those sharp spikes and crash that are problematic.